5.5 day 1 multiple angle and power reducing identities. So these double angles that we have here, you are going to need to memorize. So all of these basically, and I'll put another video on to explain or to show the proof of it. So this is for double angles. So basically, if I had, for example, sine of theta plus theta, you'd end up with 2 sine theta cosine theta. If I had tangent of theta plus theta and I expand it out, I get 2 tangent theta, 1 minus tangent squared. And if I have cosine of 2 theta, I get cosine squared minus sine squared. Or if you substituted in 1 minus sine squared for cosine, or 1 minus cosine squared for sine squared, you get 2 cosine squared minus 1. Or if you substituted 1 minus sine squared for cosine squared, you get 1 minus 2 sine squared. All 3 of these you need to know because you might need to use them at different times. So first, you need to draw the triangle. Oops. So I have tangent of 8 over 15, and theta lies in pi 3 pi over 2. So pi to 3 pi over 2 is the third quadrant. So that's my theta. So my ratio of sides is opposite over adjacent. So opposite is 8, adjacent is 15. Now, since they're going to the left and down, you need to put negatives on them. If I do Pythagorean theorem, I'm going to get 17 for the hypotenuse. So you have to set up the triangle in order to find your ratios. So what you're really trying to find is if I were to double this angle, whatever it is, wherever it is, and then draw a hypotenuse, you'll get the ratio of sides. So sine of 2 theta, my formula is 2 sine theta cosine theta. So I'm just going to plug and chug. 2. My sine ratio, sine is opposite over hypotenuse. So that's negative 8 over 17. And my cosine ratio is adjacent over hypotenuse. So that is negative 15 over 17. And when you multiply that all out, you're going to get 240 over 289. Okay. Next, I redo the triangle so that you can see it. If I want to find cosine of 2 theta, I have the option of using any of these equations. Just for the purpose of this problem, I'm going to use the first one, cosine squared minus sine squared, so you can see how I could do both. So again, my cosine squared theta minus my sine squared theta. My cosine is negative 15 over 17, and I'm going to square it. And my sine is negative 8 over 17 squared. That, you can stick this in the calculator just like it is. That's 225 over 289 minus 64 over 289, which gives me 161 over 289. That's my ratio for my cosine. Tangent is 2, erase. The tangent equation is 2 tangent theta over 1 minus tangent squared. So that's going to give me 2 times. My tangent is opposite over adjacent. Now, since it's negative 8 over negative 15, that's just positive anyway. So divided by 1 minus 8 over 15 squared. That, when you simplify, gives me 16 over 15. Because remember, this will end up positive. Divided by 1 minus 64 over 225. 1 needs to be changed to 225 over 225. So you're going to end up getting 16 over 15 divided by 161 over 225. Because remember, you have to subtract these two. And if I copy dot flip it, 16 over 15 times 225 over 161, I'm going to get 240 over 161. Okay, number 2, find the exact values of cosine 2x minus cosine x equals 0. So in order to solve, these have to be the same trig function. They both have to be cosine of x. So I'm going to replace this cosine of 2x with the equation. Remember, you had 3 choices for equations. Since I'm only dealing with cosine, I don't want to use the cosine squared minus sine squared. Instead, I'm going to replace that with the 2 cosine squared x minus 1. Then I'm going to put it in order. 2 cosine squared x minus cosine x minus 1 equals 0. Then I'm going to factor 2 cosine x, 1 and 1. I need my outside and my inside to be a negative, so that means I need this to be negative, this to be positive. Cat, go away. Stop. And then that's cosine x equals negative 1/2. Cosine x equals 1. Stop. Sorry, the cat tried to sit on my paper. And so if you look on your unit circle, cosine is negative in the second and the third quadrant. And if you look in those quadrants, that's 2 pi over 3. Third quadrant, 4 pi over 3. That's some of my answers. And then cosine is 1 at 0. So there are my 3 answers. Okay, next one is going to be kind of similar to the other one. So I'm going to kind of go back for a second and look at my equation. So I don't have a rule for cosine of 4x, but I'm going to kind of make one using my double angles. So if I look at cosine 2 theta equals 2 cosine squared theta minus 1, you can note, hold on, I'm trying to see if I can find a highlighter. All right, let me do this. Yellow. Okay, so you'll notice that if this is 2 theta, this is theta. So this angle here is double whatever this is. So if this says theta, this says 2 theta. So if I change this to say 2 theta, then that means if this is theta, this is double. So if this is 2 theta, then that means this is going to be 4 theta. So you're just kind of looking at your patterns on here. So if this is theta, this is 2 theta. 2 theta, 4 theta. And I can even make it bigger. If this was 4 theta, this will be 8 theta. 3 theta will be 6 theta. You kind of get the idea. This is double. So I'm going to replace cosine of 4 theta with this. So this is all going to go in here. So 2 cosine 2 theta, or 2x, hold on, let me erase the theta, equals, minus 1 equals cosine 2x. Because my goal is to try to get this trig function the same. Because if I can get this the same, then I can put them all on one side and factor. So I'm going to move all of this over here. 2 cosine 2, I forgot the squared. 2x minus 1 minus cosine 2x. So 2 cosine squared 2x minus cosine 2x minus 1 You'll notice this is similar to the last problem we did. The only difference is there's a 2x in here instead of a cosine. Instead of an x. So we're going to factor again. This time we're going to split this up into 2 cosine 2x and cosine 2x. And then we're going to split up 1 into 1 and 1. And then I need a negative, so this needs to be negative. This needs to be positive. Hold on, let me turn my page. Okay, so you might want to pause this here for a minute because I'm going to have to add another screen in order to solve these. So on the last screen, we had 2 cosine 2x plus 1. Times cosine 2x minus 1 equals 0. So we're going to set each one equal to 0. 2 cosine 2x plus 1 equals 0. Gives me cosine 2x equals negative 1/2. And then this one, cosine 2x equals 1. So if you remember from last semester, I'm going to kind of use u substitution. So you're going to kind of think cosine of u equals negative 1/2. Okay, so your cosine, just like we did on the last problem, is when it was u, cosine is negative 1/2. Also, take calculus in the second and the third quadrant, and the answers were 2 pi over 3 and 4 pi over 3. But this time, since there's no restrictions, we're going to put add plus 2n pi. But remember, u was originally a 2x, and the last thing you have to do is divide everything by 2. So this gives you that x equals 4 pi over 3 divided by 2 and 2 pi over 3. So that's going to give you pi over 3 and 2 pi over 3 plus n pi as some of your answers. And then this one, your cosine was 1 at 0 plus 2n pi. But remember that 2x equals that because it was originally a u. And when you divide by 2, you're going to get 0 plus n pi as your other two answers. So yes, you're going to have to go back and do a little bit of double angle work as well.